Can you all see the screen? Hope you all can see my screen and
Yes, visible.
right. So till yesterday we were talking about local repositories, right? We were making changes and those changes are on our local repositories. Now I would like to push our changes to a remote repository. So your GitHub can be the remote repository. So how do you get the remote repository and what are those remote repositories? Let's see. So you can go to GitHub and just create a free account, right? Like any Gmail account, you can create a free account. So now this works like a remote repository, but how exactly it works like a remote repository? Let us see. You can just go and create a free account, and once you create a free account, you will see the username and the account created. Now let's create a repository, a sample new repository. Okay, let me just clean up. I can create repository by any name, not an issue. Just want to clean up some additional repositories. Just let me do a cleanup. That's MFA multi-factor authentication. Just a second. Okay, so this is the repository. I'm sorry. These are all my repositories I have created. Okay, go on. Let me delete this as well. So now this is a remote repository. Here I'm creating some repository. I'm giving name as repo1 and I'm creating a public repository. So this is like a location or remote repository where I want to push. Copy this URL. So come to the local repository. This is the local repository. Okay, where I want to push my changes. So this is a local repository. From this local repository, I want to push my changes. Actually, this is the local. Okay. So now from here, I want to just push to remote. So what you have to do, add this local repository or connect this local repository to the remote one by git remote add origin, this URL, right? So now if you see git remote minus v, you can see that remote is added. Git remote minus v means verbose, that remote repository is added. So what is this origin? Origin is like a keyword or alias name which will hold the remote repository address, right? So that's holding the remote repository address, this URL. From now onwards, I'll not refer this entire URL, rather I'll refer it with origin. Means origin is like an alias or a keyword which will hold the remote repository address. So now what I can do, git push remote, sorry, git push origin master. Right, master, what is master? I'm pushing the master branch. You may push any branch. So that's how you push your changes to remote. See, for me, it says it is pushed, but whenever you are doing it for the first time, it will prompt for username and password. What is the username and password you will provide? Can anyone tell me what username and password you should provide? You should provide this username, but not the password of GitHub, rather personal access token. So how do you generate personal access token? Go to this menu. Here you will see developer settings. sorry, settings, and then developer settings. Okay, personal access tokens, classic, right? So here you will see those things. Here you can go and generate a new token, a classic one. So you can say and create, then it will generate a token. I'm not doing it, I already have it. And remember, it will be shown only one time. It will give you an option to download only for the first time. Next time onwards, it will not give you an option. Okay, so just get that available. Okay, once you have that token, how do you do that? You provide that as a password. That's how you have to push. Remember, whenever you are doing a push, you have to, for the first time, only once you have to do it. So now, being said that, your changes are pushed. Repo 1. Sorry, here it is. Okay, so master brand changes are pushed. Just 1 second, please. I'm sorry, I have to take this call.
Hello. Yes. Our trainer is on a call. She'll be back. Okay. Okay.
Hello everyone. Sorry, apologies. An important call I have to take. Actually, some mm, problem with the kids' school. Sorry. Okay. So yeah, so we did a push, right? And we can see all the changes, including all the commits. You can see here the three commits, right? You can see all the commits as well as all the changes pushed in, right? That's a simple push, and we have pushed master branch, so you are seeing that. Suppose if you want to push any other branches, right? Same command would work. Git push horizon, whatever branch you want to push, B1 or B2 and so on, and it will prompt for the credentials only once. If you have given the credentials, it's just one time ask. So git push horizon, so we should be seeing the next branch as well. See, B1 has push recent 2 seconds, and if you refresh, you will see this in the drop down. Whichever branch you want to see, you can select it, and you will see the commit history of those and the files and the changes. Is this much clear? The simple push I have just shown you, simple push.
Yes.
Right. Sorry. Mm. All right. So this is how we are pushing, and there's a local repository. If you remember, when we are talking about the architecture of Git, we discussed one thing, right? How do you create local repositories? And local repositories can be created in two ways, is what we have discussed, isn't it? Local repositories can be created in two ways. Create create local repositories in two ways. First one is just by doing git init, which is what we did, and then we push to remote. And the other method is create local repository by copying from remote, right? Already there must be a repository you might have copied from remote. How do you do that? Using git clone. You know the command, I mean the meaning of clone, right? Means copy. So copy from remote. So where is your remote? So this is your remote. Let's take some other existing repository. You can take this repository which has got some 30 branches, some hundreds of commits and all. Or else for simplicity, I'm just creating one more repository which I'll assume it has got already some hundreds of commits, and I'll clone just for simplicity. I'm creating repo 2 and create repository. Okay, and also I would like to create repository with some dummy file. You can create some dummy files. Update and upload an existing file or create a new file. You can let me upload some new file. I can upload from my local. Mm, Okay, I'm uploading some HTML file. Okay, or a readme, whatever. So I'm just creating a repository. Assume it has got some 100 files. It has got some commits. People are working on it already. Already it exists. I mean to say it already exists. Now, if you want to create, I mean, copy it and create a local repository, go to your code, copy this URL. And this already, this Git demo is already a local repository, right? So come out of this Git demo project. Come out of Git demo. So I'm on my desktop. Here I can run git clone that URL. So what happens? It will do same. It will create a local repository, right? Local repository from the scratch. Everything will be copied, including .git. See, a folder is having .git means it's a local repository, isn't it? A folder having a .git file means it's a local repository. Similarly, if I do clone also, a local repository will be created. Let me do this cloning into. So you can see here the desktop. You can see repo 2 here, right? So repo 2, right? You can see index.html. So you can open from here. Yeah. So this is the file, and this is a repository, right? You have just cloned local repositories created. How do you know that? You can see the hidden files. .git. You are seeing .git means repo2 is another local repository. Like we have created git demo on my desktop, like on our local machine. This is another repository. Am I making sense? Right? This is another local repository. Git demo is created via git init. Repo2 is created via git clone. You can create it either as this one local repository and this is the other one. Again, you work in the same way. You can create file, push, pull, and so on. Like let's suppose if I make any changes here, I can just push to remote and so on. Understood? And is this much clear, everyone? Also here, yeah, you can make some changes and push them, or you can also get the changes from remote. Okay, I have cloned, I have got a copyright. Let me show you another use case. Um, so this is now can be collaborated by multiple people. There can be multiple people who can get access to this and who can contribute to it. Here I am creating a file from UI, assuming someone else have made the changes. There are, let's say, multiple users, like different users might be creating different files. So I'm just creating a file, assuming the same. Right? So here I am creating file1.txt and some message. Okay, so this is the file and this is the commit. Now, assuming this is someone else pushed this, right? And some of the changes were here. Now, let's suppose I want to get these changes from remote to local. So what can I do? See, like I have cloned this repository some few days back, right? And many other people might have pushed their changes there. So how to get the changes back? We can do git pull origin master. Here you don't have to do again run git remote add origin. You don't have to do that. Right? Because already origin is set whenever you do git clone. So pull will bring the updates from remote to local. Right? It's like merge only, but merge is within the like branches, within their own branches, internal branches. But this is like you're getting a changes from remote to local. Right? So let's see. Git pull origin master. Oh, sorry. So the branch name, whenever I create from the UI, branch name created is main. It's main or master, anything should be fine. Git pull. See, you got the update. You see here, it got file one. The commits also will be pulled. Git log one line, you can see the commits as well. Right? So that's how you can do pull. You don't have to do git remote origin here. As you have cloned it, you already origin is set. Understood? Let me show you another interesting thing. Give me a second. Okay. I'm creating file2.txt. Hello. Comment the changes. So this is the file, right? You have got these changes. All right. So now like people are making changes here. Now the repository we have cloned some days back to get the latest updates from remote. You have to do a pull. So what do I do? Git pull origin and git pull origin main, right? That will pull it in. But there is another command which looks and sounds similar to pull, which is fetch. Git fetch origin main. So what does it do? Anyone, any idea on this fetch command? Let's see. I'm doing a fetch. It tells you, it gives you some verbose, meaning some changes were there, but you don't see them much. Right? So fetch will just tell you there were some updates, but it will not actually merge them. Right? So what is the actual command you have to do? Git pull. Pull is the one which does action. Right? So Its status, right? You're not seeing anything. And yeah, git pull will fetch the changes. So what is the difference between these three commands? These three commands looks and sounds similar, but they are different. So what is the difference? Can we summarize this? Fetch command, what fetch command does?
Fetch command will bring the changes to local repository.
You do it only for the first time. It will copy, remote, and create a local repository. This is only for the first time you do. It creates a local repository, including .git file will be created, and it creates a local repository, right? And pull command. Pull command will get the updates, right? It will get the updates. Means any updates happen, it will get the updates. Get the update means it will also do a merge from remote to local. It will merge the changes, right? Fetch will just tell you, show there were changes, but it will not do a merge, right? So these are three interesting and important commands, important from the perspective of interview also. That's a difference between them. Is this clear? Any queries in this part from anyone?
Preeti, any use case for the fetch command, like when we have to use this fetch as the changes are not applying in the local branch, or
You just want to see if there were changes or not, but if you don't want to get them into your local, that's where fetch is used.
okay.
You don't want to actually merge them or get those changes. You just want to see if there were changes or not on remote. That's where fetch can be used. Okay, now I'll show you an interesting scenario. Let's proceed. Here I'm just creating some file. Let's say file4.txt. From the UI itself, I'm making commit. Assume some others might have pushed like we are doing from our local. Okay, so there were some updates. I'm not aware of it. I'm just creating some changes, some files here. Okay, the same old story. Do you see? Because it's a local repository, untracked changes. So, okay, let me show you. Untracked changes. So what we should do, git add, git commit, -m, local repository changes, LR. I just gave it as LR. Okay, all right. So, okay, fine. I'm not bothered about what are all people moving, I mean, pushing their changes over there. I just want to get the changes, I mean, push my changes to remote. What is the command? Correct. So, git push origin main. So, if I push the changes this way, you see, failed to push some references. Updates were rejected because remote contains work that you do not have locally. This is usually caused by another repository pushing the same references. Updates were rejected, right? So why are you seeing this error? Anyone?
Yeah, because we don't have the file 4 in our local repository. Whatever you created in the
Where
remote.
the thumb rule is your local repository should have the updates from remote, right? Means whatever your local repository has got, you should have those updates from remote, right? So you should have always updates from remote before you push your changes. In layman terms, you should have a latest copy before you push your changes, right? So git pull origin. First get the updates. Okay, right? You can see the updates. One more thing. Whenever you get these updates, need to specify. Okay, see, whenever you get the updates this way, two commits will be pushed back. What I mean is two commits. Here you are seeing, right? Okay, one second. Here you are having four commits. Actually, I want to push this file 3 and 1 commit, 5 commits, but it will push 6 commits there if you just do a normal push. So what we'll do is whenever you are pulling this way, you will pull as git pull with rebase. That's what I'm talking about. You pull, we use rebase in a different way. This is what it is. Git pull with rebase. Let me show you. Git pull rebase. Already I have pulled it, right? So that's the reason it was not showing here. Yeah, already I did a normal pull. Actually, I should be doing git pull rebase, then push the changes. It will work and it will do only one. Let me pull with this command git pull origin. See, when I did a pull, changes were not appeared there. I did this git pull. 1 second. If I do this, right, it was giving me this message. Let me pull it properly. Git pull origin master rebase. Still cannot pull. You have unstaged changes. 1 second. Git status. Oh, okay. Git commit minus am all changes. So what you should do is you should be pulling those changes, right? If you do a normal pull, it will pull the commit, then one commit it will pull from remote, then another commit from here, it will push finally 2 commits. To avoid this, always do this one. Git pull origin, branch name is main and rebase, right? You have unstaged changes. Again, it is showing unstaged. 1 second. Oh, okay. Git commit minus am all changes. Still do I have unstaged changes? Git status. It got just messed up. Mm. Mhm. Something gone wrong with it. Let me repeat it with another branch. Just a second. Git check out B1. Let me go for B1. Oh, it's not allowing as well. Mm. Git branches. Okay, it doesn't have this as well. Let me just switch to some other repo to repeat this use case. I'm going to git demo. Okay. Now here, let us do some hands-on git status on branch 2. Let me go to master branch. Git checkout master. Okay, switch to master. Here also, let me open that repo. Open from the desktop git demo. Okay. Okay. Right. Let us do one thing. Let's go here to repo 1, which is connected to it. Okay, let us assume, let me create some file here. File 4.txt. I'm repeating the whole scenario again. Some commits were there on remote. Okay, regarding this file 4. And there were by now, if I refresh, I can see 4 commits. Okay, let's come back here. So here I'm creating some other file. Like let's say file 5 and some other commits. So this is a local repository, so we should add and commit. Git add file 5, git commit minus am, all changes done. Now let's say I want to push my changes. What is the command? Git push origin master. Updates will be rejected because remote contains some work. You should have always the latest. So what you should do, how do you do that? Git pull origin master rebase. This is what you should do. You shouldn't do normal pull because, like I told you, if you do normal pull, what happens? The commits, whichever on the remote, will come to local, and in local, you want to push actually this one. So, two commits will be pushed back unnecessarily. Like instead of just you are intended to push this commit, but another commit is being pushed because it's pulling the latest. So, what we can do is if you do pull with rebase, right? So you got the file if you notice. Now if you push back, push the changes now. So it allowed, and earlier there were 4. Now just 5 commits. Instead of having 6 commits, this is possible with a pull rebase. Is the scenario clear? Everyone understood the concept? Is this much clear? This is
A quick
actually
question.
a kind of one, yeah. This is actually a kind of merge without conflict. It's a kind of merge. Pull is like a merge from remote to local. Yeah, tell me, please. Go on.
Yeah. So, for example, if for whatever reason we did not rebase, so can we reset the head and then do the pull again with rebase? Will that work?
Why is reset coming in here? Both are different, right? Why should we do reset? What is a reset actually?
So when we are pulling without a rebase, it may create extra commit.
When you push back. Correct. Hmm.
Okay, but so when we were doing it, if we uh, wanted a rebase,
Changes
so
will
we
be
just want
gone,
to,
right? If you do reset, changes will be gone, changes will be discarded, they'll be wiped off from commit history. Then why should you push them back?
but
They-
if they go away from commit history, but they will still be unstaged or not.
No, everything will be lost.
Okay,
If
okay,
you
I
said
got it then.
everything will be gone, right? So this is about a pull with rebase. This kind of rebase is the one we use in reality in the project, but not the other one, not the vice versa. We don't use the yesterday what we learned, but that is the basis and that avoids unnecessary commits to be added into the current branch as the topmost commits, right? So pull is like a merge and whatever we have seen is a simple merge without conflict. Now let us see some scenario with conflict. Good to proceed? So now let us do another scenario where you get a conflict during this. Let's say, okay, again, I'm creating some file 6. All right, this is the file 6. Now let's say I'm making some changes in local. So, like already there were some changes here. I don't know, like people made some changes here, or I'm not bothered about it because there are so many changes that keep coming in, right? I'm not bothered about it. I'm making some changes here. Git add, git commit, -am sixth file, or else whatever. New file on local, some commit message. Done. So if I push now, okay, let's say I'm done with my changes. I want to push. If what happens if I do a push? What happens now if I do a push?
Merge conflict occurs because we don't have
First,
the
when we
remote.
push it, it will tell that updates were rejected, right? Because you have some updates on remote, which you should have on local, isn't it? Git push origin master. So if I do this, isn't it? This is the first step. Always a thumb rule. Before you push your changes, you should have the latest. Because like 6 months back, you might have cloned it. Right now, lot many changes are happening. You want to push those changes back. Correct? So that's where this comes in, git push origin. I mean, a git pull, you have to do a pull. Like I told you, there might be so many people working on the same repository. Before you publish your changes, share your changes with others, you should have a latest copy. That's what this forces. Now to git pull origin master, but pull with rebase. Right? Pull is like a merge. Now you would be getting a conflict. Let's see. Hmm. Do you see this file,
Excuse me.
content of this file? Like we already seen a conflict scenario in our local. Same is the case, same is the concept. Everything is same. How do you resolve is also same, but only the difference is earlier you discuss, like earlier it is your own changes, so you would sit and resolve them, right? But now you can connect with the person whom you got a conflict. They will discuss it and discuss and decide the changes. That is the difference.
Can
And
you
this.
can you go
Hmm.
over that again? What is the main concept for push and pull? You said the main.
Here the here the conflict you are seeing, right? This is coming from with the means conflict with the changes of others. So you will sit with the person with whom you got a conflict. Both of them will decide which changes should go in. In earlier case, it's all my changes, so I am the decision maker. But now you would sit with the person with whom you got a conflict and make a decision on what changes should go into file and edit the file accordingly. That is the difference between this conflict and the conflict we have seen in the previous days. That's a conflict in our local. But now there's a conflict on remote. Is this clear now? So how do you resolve it? Either accept current change or incoming change or both. So you can discuss with the person whom you got this conflict, edit the file, save the file, right? And then push the changes. That's all. Whenever you edit the file, what you should do? Add, git add, let's say file 6. Okay, then you can directly do git rebase continue. It will prompt for some message, new file, or else changes done or resolve conflicts, whatever, so give some message. Resolve the conflicts.
I have a question. Before you push the change, do you first check if for the conflict, or is the error that tells you there's going to be a conflict?
Before pushing, it will not tell. When
Okay.
pulling it, like whenever you do a pull, then you get to know if there is a conflict. Okay. And so now I did a rebase continue. It is done. Now you try to push your changes. See, finally they were pushed. Meaning push it to this one. So this file on remote should have both the lines. Is that making sense? Understood? Any questions from anyone? So this is a conflict scenario, I mean a merge scenario with a conflict on remote. Concept why you get a conflict, we already learned. Why do you get a conflict? If source is missing some comments which are on destination, you get a conflict. So that's what we are seeing here.
Any other scenarios for conflict, or is it mostly async between remote and local?
It is because of multiple people working on same files and source missing some comments whenever you are doing pull push. That's where conflicts comes. It's a general scenario, like conflict is something which is good, which is telling you that there is something wrong. You have to decide and fix the result, right? So that is a point of conflict. You get a conflict to avoid ignoring or to avoid overwriting files when multiple people work on them at the same time. That's the importance of conflicts. It's not something bad or which you should avoid. You will face them very frequently. Those are just
Correct.
for repositories.
Right. So normally a developer would be doing pull and push. So if there is a different DevOps team, so how do they get notified that there is a conflict? Does Git sends an email, or how do uh, DevOps get to know?
Every team will get the conflicts on their own repos. Developer conflicts, a DevOps engineer need not know. If it's a DevOps project, let's say this repo is a DevOps project with all configuration files, right? So multiple DevOps engineers work on it, they get conflicts. They need not be communicated or informed to others about conflicts. Same is the case if this repo one is a development project like Java project, those developers will get conflict, they will resolve it. It's a with respect to each team, each project. And also, it's not that only development project will get a conflict, right? It could be any file. Anyone can get conflict when multiple people were working on the same files.
Correct. But in some organizations, they may have a different release or DevOps team, and uh, they kind of help the development or engineering teams, and they are supposed to maintain the hygiene. So is there a way that I as DevOps engineer can quickly go through the Git repository to see if there is any open conflict, etc.? Can we see
I,
anywhere in the logs?
I did not get you, Gaurav. Why a DevOps engineer should see their conflicts? What is the purpose of it? Conflicts is like whenever you are working on the file, let's suppose I'm working on Terraform configuration files, like two people are working in my team, will get conflict and we will fix the conflict. Others cannot fix it, right? The owners of the files who made the changes will fix it. Why should others be informed or communicated about a conflict in the code? I
But
think
then,
you did not get the actual point of the reason for a conflict. Or, like I told you, let's assume Repo 1 is a DevOps project. Okay, we are having all the Terraform configuration files. 5 people are working on it. So, let's say we are all DevOps engineers. Let's say on file 4 we get a conflict. Let's suppose you are one of the person, and we will sit and we will decide like what changes should go in and we'll fix it. Similarly, it's a Java project. If it's a development project, Java developers are working on it. And DevOps engineers might be contributing to Jenkins files into the same repo. It's about only persons who get the conflict should be fixing it. No others should be informed or communicated, or others should come and fix it. Is that making sense?
yes, no, I do understand that whoever is giving the push up pull command will see the conflict, but in some organizations they have a dedicated DevOps team and they are responsible for the repository hygiene.
Repository hygiene is different from fixing the conflicts. Conflicts, only the sole owner of the particular commit should be deciding it. There will not be a separate team who will fix the conflicts. Owner of the changes who made the commits, or else the whoever made the commit should fix the conflict. There will not be a separate team or some others who will fix the conflicts. Hygiene of the repository comes about deleting the branches, about maintaining the permissions, about maintaining the hooks of the projects. That's at the admin level where only permissions will stay with the respective teams. That's not handled by DevOps engineer as a routine or a regular task. That's the
Correct. So in a scenario, okay, we assume it's a big company. We have 50 developers working on a project using the same repository, and someone says, "Hey, I have a conflict," and then DevOps, they want to schedule a meeting, get all the people who have pushed change in recent 24 hours.
DevOps
So,
engineer will not fix the conflicts of others, Gaurav. Like I told you again.
correct.
Mm,
No. The DevOps engineer will facilitate a call that, hey, you all push changes in last 24 hours. Let's connect to resolve this issue. But DevOps person need to see what all has been done in last 24 hours. So can he or how can he see?
if you want to just see the conflicts, you will see them in the local, you get a conflict. Or else if you are doing a PR, you will see under this pull request, you will see all these conflicts or the pull requests. Whether the
For the repository, for the remote, because local, again, we cannot see. Local is on each individual's device, right?
right. Mm.
Okay, so we can see the remote uh, commits for a period. We can filter those.
Yeah, yes, yeah.
Okay.
So we have seen conflicts merge or pull with conflicts and without conflicts, right? So now let me talk about another important feature on remote repositories, which is pull requests. They are called pull requests or merge requests. They are called merge requests on Bitbucket or pull requests on GitHub. Okay, so how it works is, like some days back I explained. Let me just come back. There is a master branch, right? No one will be able to push to master branch on remote. No one can push. Here I did push origin master, but no, master branch will be a protected branch. No one else can push the changes. So what you will do, anyone, they'll create some dev branch from master, make changes here, test it out, run the CI/CD. If it is working fine, that branch will be merged into test branch, deploy into run CI/CD, deploy to test environments, and then another new branch will be created called prod, and then create a CI/CD, deploy to prod environment, right? So this is how it works. So that means after this dev, like we are merging to test. From test, prod is master branch. But how do you push to master branch? How do you merge to master branch? Directly you cannot do. Will raise a PR, right? That PR will go for the approvals. The managers or the senior people will review the changes. Once they are good, then only they'll do the approval. This is the actual concept. So see here, if PR, I don't have actually another branch. You might have pushed different branches from local, or else yeah, I have here something. Let's say I'll edit this file, some dummy line I'm writing, commit. Now I made some changes on B1. Assume that they were pushed from local. Okay. Now I want to merge it to master. Okay. What I can do, PR. First of all, we should protect the branch. How do you protect? Settings are there. You will not have access to settings of every repo. They'll be set at the project level or the account level, and only those will be fixed across the org. You cannot just go and write these rules. Just for your simplicity, I'm showing. See, here you can make the default branch or the master branch as a protected branch, so that your pushes or pulls, see, all of them will be blocked. The default branch is considered as base branch against which all pull requests and code are automatic unless you specify a different branch. Okay, let this be. Allow merge requests. No. And all commits head of the branch commit. Hope that is saved. Actually, there are settings where branch can be protected. Your master branch, if it is protected, you can't make any commits. Let me check if it is allowing. Commit branch there, it's allowing. There are somewhere we can put the rules or branches. Add branch rule set. Yeah, you can create a rule set and add the rule set. So new branch rule set, branch name is master, which should not be allowing any commits. Rules, restrict creations, restrict update, deletions, restrict the pull request from merging. I'm just seeing if we have already default ones. What are protected branches it was showing? Add branch rule set. Rule set name is test. That's just a rule set name. Target branches. Add target branch. Include default branch. Default branch means I have added master if I remember. Restrict creations. Restrict updates. Restrict linear restrict. Pull request before merging. Require a pull request before merging. Okay, so approvals. Do you need 2 approvals or 1 approval? Because we don't do this every day, we don't remember these conditions. Like I told you, right? We don't set on every repo. They were set across the project, across the org, and only admins will have permissions. It comes from org specific rules. So you don't have to change them or configure it. So generally it would be set something like this and create the rule. Okay, that rule name is test rule. I think the test rule and branch rule set. Okay, that's again one more. I think it should be working now. Let me try. Here it should show as a protected branch. I don't see it's working. Whatever, just understand there will be some rule sets you can apply and you can make the branch as protected. So direct commits will not be allowed. What you have to do, I made some change on B1, right? You can go here and raise a pull request. Create a pull request, new pull request. And from where? From B1 to master. I just want to see cannot automatically merge. Okay, it's showing that. Don't worry, you can still create a PR and it would need reviews, right? Give some name, some description about the change and create the PR, right? It should go to the approval, checking for the availability of the branch. Has conflicts must be resolved, right? Resolve the conflicts and resolve it. And then approval should have there should be approvals who can only merge it by reviewing it. That's how you have PRs to stop direct commits. Is this much clear, everyone?
Yes, and Priti, how would I know that there is something pending my approval?
Meaning?
Any notification?
Okay, yeah. Yes, you will have notifications. Notifications would be triggered on that. Whenever if it is means you can add the approvers here. See reviewers or approvers, right? If from the people, from the collaborators, if so many people are added to it, those names you will see here. Here we are not seeing, those will be reviewed. See, no reviews, no reviewers. Assign yourself.
And and do we get email as well, or is just within the tool we'll see?
Email notifications you will get. That's again another subscription on GitHub.
Okay.
Enterprise version should be there. Okay. Any more queries?
Yes, sorry, one last question. So when we receive the email, can we approve via email also, or we have to come into tool and approve?
You have come into this one.
Okay.
Through the email, it will give you a link through which you have to come in here and approve. Because you have to
Okay.
review the code, right? So you have to do it here on the GitHub or Bitbucket.
Understood.
Okay. So that is pretty much on remote side. Majority of the things we do locally means people develop the repositories locally, they make changes, they will be making their code ready, and then they push to remote, right? So these are the things we do on a remote. Now, another, see, till now what we learned is we learn Git from the perspective of managing our files. We can also learn Git from the perspective of the CI/CD part, right? Meaning, like we were working on this, whenever there is a change here, means a commit, it should trigger the CI/CD, right? That's where Jenkins comes in. Now we learn Git thoroughly and we learned it with respect to the code changes here. Now we'll be proceeding to the aspect of learning Git from the perspective of CI/CD. But before that, we should learn Kubernetes. I'm sorry, Before that, we should learn Jenkins. So the next part would be getting into Jenkins. But again, before learning Jenkins, we should have some basic idea of setting up Jenkins on different ways. Like if you want to set it up on Jenkins, some Linux, some Linux basics. So we'll be going through some Linux basics in the next class, and then we'll get into Jenkins. Why you should learn Linux and all, we'll see. It's not just specific to uh, Linux is not just specific to Jenkins. We will be learning it for a reason for other tools also. We will discuss all those things. Why you are learning Linux, how much extent you should learn Linux, all of that we'll discuss. Any more queries? Hope you're all actively doing hands-on. Use the WhatsApp group, post your queries, and that's how you can get into it. Any questions from anyone?
Yes, I have a question. I'll
Mm,
just use the screen that you are sharing. So on the left, you have uh, there's a dev CI/CD, there's a test CI/CD, and then there's a prod CI/CD. But I read somewhere that the Googles and Amazons of the world, they don't have so many pipelines. They just use one or two golden pipelines, and within the pipeline, they have the guardrails set up. For example, once the code is checked in, it would trigger the QA tool. For example, yeah, your Excel queue or something is connected, so that will do your test part. And once the test part is completed within your pipeline, but then your uh, infosec tools in the pen test or SonarQube would be triggered, and again there are some guidelines, no critical, 90% coverage, etc. will do. After that, it goes to a staging area. So why do we need three different CI/CDs? Can't it be managed in just one?
I have highlighted here test, the prod, or the deployments part. CI/CD will be triggered on dev environment, deploy to dev environments, local testing, local environments, then deploy to test environments, then deploy to prod. Here I'm focusing on highlighting the deployment to different environments, from lower environment to higher environment. Wouldn't you deploy to different environments before you take it to prod? That's what I highlighted here.
But why do we need three different pipelines? Because each pipeline costs money.
Here I am talking with respect to the branches. Those are not three pipelines. You are merging the changes to test. Test will trigger the CI/CD. CI/CD means here I meant to deploy it onto test environment and then to prod environment. There is no hard and fixed rule that you should have only these many pipelines. Too many pipelines means it's costly. No, that's not the case. Each pipeline, depending on the environment, will have different stages, different phases, or different aspects of testing. Like in test, when you are taking to test deployments, there might be certain stages implemented, like code scanning and all, or else it might be done at the very early stages in dev pipelines itself. Those need not be executed again on the prod ones. So those restrictions varies from again company, project, and so on. There are no rules that you should have these many number of pipelines. Pipelines costly in the sense it also depends on how they were designed.
Right.
All right then. Anything else? Anyone from any others? So this completes the Git from the perspective of managing the files. We will again use Git from the perspective of the CI/CD part. Oh, I mean from the yeah, to trigger the pipelines, wherein we'll do it with Jenkins. So We'll get into Jenkins, we'll learn Jenkins, and we'll come back and integrate and get started with those pipelines. Right? So that is the agenda. Tomorrow class, we'll get started with Linux basics. Why you should have Linux basics and all, we'll again discuss and get into that. So that is all from my end for today. Please complete your hands-on, complete your quiz and the assignments. Any questions, post it in the group. Okay, we shall close it here for today. As today it's a Thanksgiving Day in US. I don't want to take all your early morning time. And yeah, happy Thanksgiving and bye everyone. Good day. Thank you all.
Thanks, and same to you all.